Now once you have the value for all the phi's here, you can write down the final equation in terms of phi1 can be a function of phi2, phi3 and phi4. And in terms of the phi1, you can write down the equation that you got for the phi1. For the phi2, you can write down the equation that you get for the phi2 either in the modified form or in the original form. For the phi3, you can write down this equation directly, v by c, or if you know it is equal to the Mach number, you can write down the Mach number. Phi4, which is an angle of attack, so you can write down as such here in terms of alpha. So overall, we are interested in getting this final equation that shows you the relationship between different dimensionless number. Now coming back to the question, what is asked in the question here, we need to calculate at what speed and pressure should they run the wind tunnel in order to achieve the dynamic similarity. So this one was basically the model airplane wing, and we need to compare this model airplane wing with the prototype. So we have to calculate what is the speed of the model and the pressure to get the similarity between the model and the prototype. To solve this one, I have prepared I have written this one by myself in terms of getting the similarity between the model and the prototype. Now for this particular example, if we use the Reynolds number to get the similarity between the model and the prototype, we can have the equation rho m, rho for the model, u for the model, d for the model, and viscosity for the model. So this is the Reynolds number for the model, and the right hand side we can have the Reynolds number calculation for the prototype. So you can cancel out the terms that are same. So the equation that we get here, um, that is the velocity for the model, dm is the size of that airplane wing or the length of the airplane wing. On the right hand side we can have the velocity of the prototype, dp represent you the length of the airplane wing. So the ratio between the scale of the model, it is 1:10. So if the model is 1, so the prototype it can be 10. So from here, by rearranging this equation, we have found that the velocity of the model, it should be equal to 520 meter per second, which is 10 times higher than the prototype. So the velocity, to get the similarity between the model and the prototype, we have to run the model with a speed of 520 meter per second. Now there is another relationship we can have from this equation. Now here we have to use, we can rely on the Reynolds number. We can rely on the Reynolds number to get the similarity between the model and the prototype. Then what is the next dimensionless number we have in the equation is the Mach number. So it can be used to compare the speed of speed of the model and the prototype with the speed of the sound. So for the prototype, what was the actual speed we are provided in the question, that was 52, and the speed of sound, it is 346 meter per second. So the Mach number calculated for the prototype, it is 0.15, that lies in the subsonic range at 1 atmospheric pressure. Now for the velocity of the given model, that could be 520 meter per second. If you calculate the Mach number here, it can become equal to 1.5, which lies in the subsonic range for at the pressure of 1 atmospheric. So what we see here, that if we run the model with so much high velocity, the Mach number, it can become so high that it will exceed the physical limits of the system. So what we can do here, if we increase the pressure of a wind tunnel, we can reduce the speed of the model proportionally. So what we see here, for 5 atmospheric pressure, the speed required will be 5 times less as that of the calculated 520 meter per second. Now this is the speed that we calculated at 1 atmospheric pressure, but if we increase the pressure to be 5 atmospheric, then this velocity will become 5 times less than this velocity. Now at 5 atmospheric pressure, the Mach number that you can calculate, the velocity could be 5 times less than that of the actual velocity for the model. That comes out to be 104 divided by speed of sound. Now the Mach number that you got here, it is 0.3, which lies in the subsonic region. So what we have seen from this example, that we have developed the dimensionless numbers, and we have developed the functionality between different dimensionless numbers, and then we use these dimensionless numbers to make a comparison between the model and the prototype. We have used the Reynolds number, we have used the Mach number. So from the Reynolds number, we have calculated the velocity of the model, and then we compare this velocity with the Mach number to see the physical limits of the process, of the physical limits of the operation of the airplane wing. So we have calculated the Mach number, and then we see that the new velocity, if we use for the actual experimentation, it is very high. So we can actually increase the pressure of the air to reduce this velocity. So we have increased the pressure from 1 atmospheric to 5 atmospheric pressure. So we can reduce the Mach number to 0.3 that lies in the region for the subsonic. So this is how we can perform different experimentation, and we can use the dimensional analysis to make the comparison between the model and the prototype, and how we can change the conditions of the environment or the experimentation to get the similarity between model and the prototype. Now this is example number this was example number 7-8, and this is very good and detailed one. You can have the same example here, similar example here, example number 7-9, which is about the friction in the pipe from your book. So the parameters are given here. Okay, so what you have to do here, you have to read this question here, and then you have to write down the equation, and then select the number of repeating parameters, which parameters you can choose or not. You can see that one, and then you can write down the dimensionless numbers for a given problem, 5.1, 5.2, 5.3. Then you can write down the final equation in terms of the functionality between the dimensionless numbers. So I will not go on this example. You can try it by yourself, and if you feel any difficulty, you can send me an email during the office hours or during your lecture hours. Thank you, everyone.